Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 149 and a half. And quick reminder, housekeeping, please follow Identity Office Hours on LinkedIn. That really helps us a lot to get the word out. Our guest today, Aaron Parecki, Director of Identity Standards at Okta, returning for the third time. Welcome, Aaron.
Thanks for having me.
We're not going to do intros because you, as a returning guest, I'll reference in the notes the first episode you were in. It was a while back. It might have even been a year ago. But we'll skip the intros and just dive into the topic. We are both returning from IAW, and we talked about a new standard, OAuth. Client, wrong one. Yeah, OAuth client ID metadata document. And I've been doing a little bit of thinking about this one. But maybe we could just start with the basics. And do you think it's safe to say that this standard is somewhat similar to SAML SP metadata? And one of my complaints about OpenID, from early on, was that the RP had no identifier. Like in SAML, the SP had an entity ID, but in OpenID, we
Yeah.
had no definitive way to reference a client. And then also in SAML, SPs could have a metadata URL. So am I on the right track here?
It's an interesting point. I hadn't actually considered that, interestingly. But yeah, no, it is. It is the so backing up a second, the short version of this spec, which is not an RFC yet, just to be clear. It was just adopted by the OAuth working group like a couple weeks ago. Which is a good step in that direction.
Yeah.
But the short version is basically there is a bunch of metadata about a client, like information about the client, like the name, the logo, the redirect URI, whatever properties about the client. And this is a way to have the client host that information about itself at a URL, and then use that URL as the identify client ID. So instead of pre-registering clients as we would normally in OAuth, the client sort of brings its own identity.
I'm hassling Aaron in the background about his OAuth being backwards.
Oh, well,
Aaron,
why would this video platform default
there you
to
go.
mirror the video on the stream and not just for me?
I have no idea, but no, this OAuth looks a lot better than Hatha OAuth.
Yeah, there we go.
So you're saying that, so this, reminds me, I remember having a similar conversation with Spiffy people about, in Spiffy, there's a URL that you get when you do Spiffy registration. And the idea that in talking with Spiffy people, they would say, why can't I use that URL also as my client identifier?
Mm-hmm.
But this goes a little bit beyond that, because we're not just talking about the identifier, we're also talking about other details, right?
Yeah, so it's the identifier, but then you can find the information about the client at that URL because you can actually go fetch it. So the let me back up one more step here. The reason this is important is because and again, not everybody is going to want this.
Yeah.
I'm not saying everybody has to want this, but what I am saying is that some people have a scenario where they want a client that has never before been seen by an authorization server to be able to do an OAuth flow and get an access token.
Mm-hmm.
So the family of things that work that way are things typically like open source software servers that you can install yourself. So for example, Mastodon.
Yeah.
You can install Mastodon on any number of servers anywhere at any time, but the Mastodon clients are developed by totally different people at totally different rates. And obviously it doesn't make sense for the developer of a Mastodon iPhone app to go and register for a client ID at every single Mastodon instance in the world. Like that doesn't make sense, right?
In
So
fact, I think we had a conversation on this very topic about Mastodon because I
I think
ran
we
into the
did.
Mastodon CTO at FOSDEM last year, and we mentioned about, how Mastodon's particularly a good example because if you repost on somebody else's Mastodon server, that Mastodon server, we don't want to have to force dynamic client registration or force multiple client registrations. So how do you correlate these different interactions?
Right, right. So the fundamental issue is that when you want the world to work that way, where anybody can download an iPhone app and then point it to their own copy of some software, then pre-registration of the OAuth client does not work, and that forces us to look to other options. And so this is Mastodon's a good example. WordPress is a good example, and then you get into other variations of that where it's like BlueSky, same concept. There's any number of BlueSky host servers, and then of course most recently everybody's favorite new technology MCP, where again the same premise is anybody can spin up an MCP server and use it with clients that didn't know about that server ahead of time. So pre-registration is not possible, and that's the common theme throughout all this is with that pre-registration of client identities at authorization servers is not possible fundamentally, which means the current model of using OAuth with pre-registered client IDs just doesn't work. So
Yeah.
that's the thing that's driving this need.
Um, Now, can I just ask? One thing I initially thought when I saw this was that it doesn't preclude client registration. Could you perform dynamic client registration and specify this identifier and metadata mechanism?
Um, Sort of. So strictly speaking, no, because the dynamic client registration spec I'm pretty sure, does not allow the client ID to be an input parameter.
Hmm.
Right. So the premise of dynamic client registration, the spec, is that the authorization server accepts the metadata in a post request and issues its own client ID. Right. So like literally speaking, no, but conceptually, yes. And the reason is because um, you could imagine an implementation of this spec, the client ID metadata document spec, where you don't want the scenario of any number of previously unknown clients showing up and using the authorization server, which means you want some sort of registration. And the way you could do that is by making it so that rather than the developer of the app, maybe it's actually like the IT admin of the company or the person who runs the website would, instead of typing in all the metadata and then generating a client ID, would take the client ID URL and put it into an admin interface where it would go fetch the metadata and then register itself. And then unknown client ID URLs wouldn't be possible to be used. So the end result is that you can still limit what clients are using an OAuth server, even with the client ID metadata document, even though that isn't necessarily like the majority of the implementations I would expect to see.
Yeah, it makes me think, um, like, let's say aaronpreki.wordpress.com. You might want to prevent somebody, you might want to register your site proactively so nobody else asserts that name because whoever asserts it first is going to potentially control it then, right? Because there's
Well,
no,
no. So other way around, right? Where
well,
it's like,
I guess you have to
um,
control the URL. So maybe that's a protection.
oh, yeah. So let me get into that, but let me flip it around to the realistic scenario. It's something like well, let's say it's my company's WordPress blog, right?
Hmm.
And my I let my employees edit the blog with three applications, right? There's the WordPress iOS app, there's the maybe some third-party blog editing tool, and maybe there's like I don't know what's like one of those social media posting things like Buffer or something, right?
Hmm.
Where it's like these are the tools that we use at the company, and I explicitly don't want anybody to use other tools. So I could go and I could put in the client ID URLs for those three clients into my dashboard and say only accept these client ID URLs, right? That way, someone who tries to use some other app that I don't want them to, they would get an error when they land at the OAuth screen with an invalid client ID, right? So that's the scenario that I'm talking about. The question that you asked though is or the follow-up question you asked was like, what's stopping somebody else from using a URL of another app, right? So if
Yeah,
I built an app, um, and it's running on a web server, at exampleapp.com, and there's a client ID metadata document there at that URL. Um, that's it's a URL on the web. Anybody can find it. Anybody can
right.
fetch the data, which does mean anybody can take that client ID URL and use it in an OAuth flow to any server. So what is the mechanism to make it so that only my code can actually successfully complete an OAuth flow with that client ID? And that's where things are. Well, there's different levels. There's different answers depending on whether we're talking about web server based apps, mobile apps, or desktop apps.
Okay.
And I can definitely get into the weeds on this if you want.
Let's talk about it a
'Cause-
little bit. My
yeah,
initial take on this is that there's also probably a JWKS URI, right?
yeah,
Where we're publishing the public keys. So even if somebody asserts that that's their metadata, they wouldn't be able to authenticate with the corresponding, they wouldn't be able to sign the challenge in order
that's
to assert the control.
yep,
How
that's
would that
exactly it.
differ between web, mobile, and is it has to do with how do you get the URL, or what's the difference between web, mobile? What was the other one you mentioned?
Desktop.
Desktop. Yeah.
Yeah. So web apps are the most straightforward and the most secure option in this, like in most of OAuth, where the the web server, like if my app is literally running on a web server, it means that it can publish this JSON file, including a JWKS URI with public keys that web app controls the private key for, right? So I can have a private key on the web server that nobody else can get to, and then I can publish the public key. And then, yes, like you said, any requests to any other OAuth server out there can be authenticated because my code can use the private key to sign a JOT and use that as client authentication as described in 7523, I think, RFC 7523, also called private key JOT client authentication. So that is straightforward for web server apps. So now let's take the mobile app example, which is this kind of middle ground. The reason it is different on mobile is because one, mobile apps can't host
Mhm.
URLs,
Right.
like can't serve a URL on the public internet. So in order to use this with mobile apps in the first place, I need to go to the website for my mobile app, which there's probably a website, even if it's just like a splash page to download the app, right?
Yeah.
Put the static JSON file on that web server, and then use that client ID in the mobile app source code. Um, so now we're back in the world of what's stopping somebody else from just making a mobile app that uses my client ID.
Yeah.
And the answer is either nothing is stopping them, or if you want to add another layer of security, there is an OAuth spec for this. It is in progress still, but it's nearly done. And it's called attestation, client attestation based, no, attestation based client authentication. There we go.
It's
Add,
ABC. That's how I
it,
remember it. ABC,
okay, there we go.
attestation-based client authentication.
Yeah.
Yeah.
And the idea here is that because iOS and Android have native APIs for the way that like totally separately from OAuth, iOS and Android have these APIs where the app can request from the operating system a signed assertion
Hmm.
from Apple and Google, and then send it to a server where it can be validated.
Right.
They work slightly differently between the two platforms, but conceptually it's the same thing, where it's a statement by Apple and Google that says this app is running on a legitimate device and it was downloaded from the App Store, and this whatever, right? So attestation of the client identity.
Right.
Um,
And by the
so
way,
the
Google calls that, I think, the integrity API,
yeah, yeah, yeah.
and Apple has a different name for it. But it'll also
Apple's
tell
is
you that the app hasn't been modified, which is
yep,
interesting because we don't want to talk to the app if the app's been hacked, and it'll tell you if the device has been rooted, which
yep,
is could be
totally.
important also. Yeah.
Yeah. So all these kinds of attributes about the app running on the device get signed in an assertion that Apple and Google generate that can be validated. So to connect the dots here, the app can generate that assertion or get the assertion from Apple, send that to a backend that the app developer runs to validate it.
Right.
That backend is where the private keys would live for the JWKS URI of the client metadata.
Hmm.
So that app's backend can then sign a JOT, return it back to the application, and the native app can use that JOT as client authentication in future requests up to the OAuth server.
Yeah. So one way to think about this is that so so the spec that you've defined um, provides a type of metadata discovery mechanism, um, your client metadata, and the ABC authentication, as I like to call it, um, provides a mechanism for secure client authentication. So they're complementary. Um, Although ABC authentication, which came out of the wallet world, it can be, I think people might think it's a little complicated. Do they generally want you to use Depop also? Um, it's,
So, I mean, these are all like totally separate concepts, right? So, and actually, this was an important conversation, and I realized I slightly misspoke a second ago. An important aspect of that ABC attestation-based client authentication document is that it does not actually take the slot of client authentication in the OAuth stack of specs. As in, it's actually a totally new header that gets added to the request. So client authentication can be, a shared secret using HTTP basic auth, or it could be a shared secret using a post request parameter, or it could be signing a JOT that's used as a client assertion, which is described in 7523. The attestation-based client authentication, despite being called client authentication, does not actually use any of those parameters. It's a totally separate header that gets added, and that was an intentional decision so that it can be used alongside all these other things in the case that you can, for some reason, distribute a credential to the application and have it be a actually actual credential in the client. Anyway, all of that is a totally separate concern from Depop, which binds access tokens to a private key. And there have been a lot of discussions in the working group also about is it a good idea or bad idea or not? Does it not matter to use the same private key to sign the Depop requests as it does these client attestation JOTs? And there's various versions of the answer depending on what you're deploying. So all these things are just like, this is the fun thing about OAuth is it's very choose your own adventure. You get to like pick from this wide menu of features that you want depending on your threat model. And this is just now one more angle to it.
so as an AS vendor, I'm going to ask you a somewhat self-interested question here. Let's say I'm an AS vendor, just hypothetically, and I want to support OAuth client ID metadata documents. What do I have to do? What are the changes?
Yeah. So the first question I will ask is, do you want to support this sort of open world version of OAuth where unknown clients can be used at the authorization server for people?
Let's
That'd be the first
hypothetically
question.
say yes. Yes.
Okay. So if yes, then
And let me just sort of play back my assumption here. So what you're saying here is that the client is not going to previously register through DCR. It's going to present this URL. I'm going to fetch the metadata, and then I'm going to allow this client to obtain a token through that.
yep.
That's what we're talking about.
Yeah, exactly. Yeah. So the first time so in this world, in this open OAuth world where open OAuth, the irony of a lot of things calling themselves open that are actually not at all open is it's really funny. Anyway, in the open world version of OAuth that this enables, what it means is that an authorization server can, for the first time it sees this client, will be in an authorized request, and it won't have known about this client before, and that's intentional. That's by design. And there's a couple of security considerations around like how you fetch metadata and how much of it you trust, and et cetera, et cetera.
Yeah.
And again, depending on what your threat model is, the answer of what you do and how much of this will be different. One of the recommendations we do make in the spec, though, is that you actually first authenticate the user before you fetch the metadata. So imagine like you user starts an OAuth flow from an application and they're not logged into the authorization server, you're going
Okay.
to ask them to log in first, right? And we recommend that you do that before you then fetch the metadata, just to avoid the scenario of having a endpoint that does not require being logged in be used to fetch data from this URL.
Okay.
Minor detail. Point is, get the user to log in, then you're going to show this consent screen. So you go fetch the metadata, and the metadata is going to include client name, client logo, the website, maybe the private key, public keys. Don't put your private keys in the document.
Yeah.
Um, public public keys,
I do that
redirect
all the time,
URIs.
by the way. So it's not just you. Yeah.
Yeah. Hopefully not putting the private keys in the documents all
No,
the time.
just saying private key because like I feel like I'm pre-wired to say private key first.
Yeah. Yeah.
So
Anyway, so you need to build the consent screen to show the consent screen to the user, right? You need to
yeah.
say like, "Hey, user, do you want to allow this application to read
Mhm.
your emails or whatever the prompt is?"
Okay.
So at that point, you go and fetch the metadata, and this is where you can again make some implementation choices around how long you cache the data, whether you have your own like sort of copy of the data that you keep permanently, or just treat it as totally ephemeral. But in any case, you show the consent screen to the user, and then continue on with the rest of the OAuth that you normally would have done, which is if they click yes, you generate the
Okay.
authorization code and stuff.
Let me dig into this a little more. So the request that we're seeing from the client is at the token endpoint.
No, it's at the authorization
At the
endpoint.
authorization endpoint.
Yeah, well,
Okay.
first it's at the authorization endpoint.
Yeah. All right. That answers my first question, which is how are we going to get to the authorization endpoint?
Yeah.
Oh.
You could technically combine this with any other OAuth extension. So, for example, push authorization requests,
Mhm.
where the flow starts with the post request, not at the authorization endpoint. And this would still work. And again, the way I would expect you to implement this is that in the push authorization request, that will include the URL. I would not expect it at that point. I would imagine that you would just store the URL internally, create your request URI for PAR, return the request URI to the client. It will then go to the authorization endpoint with the request URI where you retrieve the state that you stored, and then do what I just described. Make sure the user's logged in, and then go fetch the URL.
One thing I'm a little confused about is that you said that we're going to do the consent. Um, um, so we're going to authenticate the user before we, but in the process of the consent, we would need to fetch the metadata to figure out what this client is, what's its name,
Yep.
what's its logo.
Yep.
So
So the order was just when the user hits the authorization endpoint,
yeah,
first make sure they're logged in.
yeah.
So if they're not logged in yet, get them logged in.
Ah,
And then you need to display the consent page. So obviously before you display the consent page, you go fetch the metadata.
okay, I
The point I
understand.
was making was just don't fetch the metadata before the user's logged in.
Yeah, yeah, I get it. So I was conflating authentication and consent as one, but really it's two
Yeah, no,
steps.
it's definitely two distinct steps. For first party apps, people do tend to conflate them as one thing because they don't really have a consent step for first party applications. And I guess what I would say for this, because technically you can implement this for first party apps too, although I don't know if it really makes any sense, but you could do it. I would say that, well, and again, this is not unique to this document. It's actually advice straight out of like OAuth RFC 6749. If the client is a public client, as in if it doesn't have credentials,
Hmm.
don't auto approve a request. Like make sure that there is a consent page because that a public client can be impersonated. And that's true with the client ID metadata document. It's true with a regular client ID pre-registered or not. So if you are using it with first-party apps, I would still expect a consent page of some sort so that the user has to click through.
Right. One thing that's interesting is that, I mean, just thinking through this in my head about how we would implement this as a AS, I'm still going to have to make a client entity in our database. Like, I still need a record of this thing. So
It,
in a
de-
way,
it
it's
depends.
another way to do client registration from my perspective.
You can absolutely think of it that way. Yeah, is that if you have a database of clients and you want to continue to maintain that database, you can absolutely think of this as a sort of automatic registration, where the client ID shows up and you haven't seen it before, so you go fetch it and you add a record to your database, and then you have your own internal client identifier that you use for relations to other tables and stuff. Totally fine. It's also possible that you don't implement a client database for this. Actually, I have an implementation that works that way, where it does store like the list of authorizations that have been used or
Yeah,
granted, and it just stores the client metadata in each row. So it's horribly inefficient because it's duplicating the client name all the time.
right.
But we're talking about this working at a scale that is never going to be a problem for this, because it's like, well, I'm the only user of the
Yeah.
software. So I wouldn't recommend that for implementation that's going to scale to millions of users. And that's where, yeah, you would have a database of client records, and you have some sort of policy of when you refetch the data when it comes in a new OAuth request, and don't use your cached, your cached data. But totally, yep.
For the Mastodon example, um, I guess this prevents the duplication of the client entity because at least you have a correlatable identifier in the URI.
Yes. So what we didn't talk about yet is the alternatives to this of like, so again, like you have to start with the assumption that there are systems and people who want to let previously unknown software work with their authorization server.
Right.
If that does not apply to you for enterprise or whatever, like fine, but I'm not saying you have to do that. But there are people who have this problem.
Yeah.
So what has happened so far is people will look to the existing solutions and usually will land on dynamic client registration, the spec. And that spec works by the client, before it redirects the user to the authorization endpoint, it needs a client ID. So it will post all of its metadata to the server and will get back the client ID. And then it uses the client ID to do OAuth like normal. And this leads to, like you just hinted at, a number of logistical challenges that have been in practice extremely a big problem. So there is, for example, because the client just shows up and makes a post request, there's no authority of that information. So there's no reason to, you can't be like, oh, just because this client said it's Google Docs, it does not mean that the next thing that says it's Google Docs is the same client. So you have to treat them as separate clients for purposes of, did the user already grant permission, or how many is the token associated with the same software or not, right? So you have to treat those as separate things. And that means that essentially with dynamic client registration, you're in a situation where your database of clients is only ever going to get bigger for every single time somebody logs in. And the other problem with this is, because there's no clear lifecycle management of clients for dynamic client registration, as in a client shows up, user logs into an app, does DCR, gets a client ID, the user logs in, and then it's going to use an access token. And if that access token is valid for a month, which is common in some cases like Mastodon, where you don't want to relog into your mobile app all the time,
Yeah.
that client's never going to use that client ID again because it's just using the access token. And some authorization servers then, if they're not keeping track of whether access tokens are being used, might be like, oh, well, we haven't seen a new OAuth grant for this client in 6 months, so it must be okay to expire it.
Yeah.
And there are many examples in Mastodon and other software of people writing these kind of cleanup jobs where they clean up old client IDs that haven't been used.
Yeah. Glue
But the
server,
problem is,
by the way.
what?
Glue server does that.
Oh,
We
yeah, yeah.
clients. Yeah. It's configurable, but people do it.
Totally. And I mean, and you kind of have to, because otherwise you just end up with an infinitely growing database of clients. And what it means, though, is that because the client has no way to know that its client ID has been deleted,
Yeah.
if it goes and starts a new OAuth flow, it'll just fail with invalid client ID,
Happens to
which
me
is
all the time because I tend to like make my expiration short. Yeah.
yep, yep. And then what you end up with is app developers who don't want to send their users to a dead end will re-register for a new client ID every time a user logs in,
Yeah. Safe.
because that way it will work.
Yeah.
And now you have, not only do you have every single mobile app download of your app registering a client ID, each of them is registering a new client ID every time a user logs in. So you've just like compounded the problem, right?
You mentioned desktop. I didn't get to that. We talked about mobile. but we didn't actually
Yeah.
talk about
Oh yeah.
desktop. How is desktop different than mobile?
Yeah. So with desktop apps, they are, similar to mobile apps. They get downloaded into the device and run there, which means they have the same challenges of not really being able to provision credentials. So
Or
they're
publish
considered
a
public
URL?
clients. Um, Sorry?
Or publish a URL that's
Yeah,
read.
yeah, yeah. They can't host a URL of the document. Yeah, totally. So same problem as mobile for that. The downside is that the platform attestation APIs don't exist on desktop operating
True.
systems.
Yeah,
So they don't
exactly.
have the equivalent of Play Integrity or Apple's app attestation. So there isn't a good story or a standardized story for how to deal with this problem on desktop. So
Fascinating.
the only thing you can do is kind of leverage other channels you might have that could establish app integrity. So things
Mm,
like if you are running MDM on the devices,
right.
you could hook up your own kind of thing that checks whether it's MDM, and tie it together with maybe the same mechanism as the attestation-based client authentication. But none of that's standardized, and we haven't seen like too many of that
Yeah.
being used yet.
In the wallet space, there, you really don't want a client record because you don't need a client ID for every
Mm.
single wallet you interact with. And that was one of the origins of ABC authentication. Um, was this is like we don't want to register every single client. Um, I want to pivot a little bit to a related topic, which might confuse people even more, which is software statements.
Oh
Um,
yeah.
because we mentioned, the thing about client registration is that if it's open to anybody to register a client, you can't really trust client registrations.
Yep.
So software statements, I think it's in 6749 even mention of it.
No, it's in. I don't think so, but it's in the
Maybe
dynamic
not.
client
It is in the
registration
dynamic
spec.
client registration spec, is where it's first mentioned. Um, but ecosystems like open banking use this, where a trusted authority might issue a software statement to a client, and the client presents this at dynamic client registration. Um, is there any in your metadata for your client ID? Um, is there any way to specify a software statement, or do you see that as something that might actually be beneficial?
Yeah. So it's an interesting question. Two things. First of all, the vocabulary that goes into the client ID metadata document is directly references the dynamic client registration spec. So that's the spec
Hmm,
that establishes the vocabulary for clients, as in like
okay,
what are all the properties that clients have, and that can include properties defined in extensions, but
hmm,
DCR itself defines a bunch, and software statement is one of them.
right,
So by inheritance, the client ID metadata spec does have a software statement property in that file, right? So that said, for this kind of thing like mobile apps, it doesn't really make any sense because the metadata file is on a web server, and that's where the software statement is. And that, how do you tie that to the app download, right? Doesn't
yeah,
really work. For DCR, though, with mobile apps, you could start going down this path. And we had a whole discussion about this in the MCP working group around how do we solve this problem for MCP, because MCP has this problem of wanting to enable this open world ecosystem, and they currently did it with DCR and are hitting a bunch of problems from people who either have implemented DCR and have all the problems we just talked about, plus other ones we haven't talked about yet, or they don't want to open up DCR because they don't want a public registration endpoint. So
right,
one of the options considered was software statements. And the problem is that software statements is, like many things in OAuth, a generic and a framework, and doesn't actually prescribe any particular thing. So it is a way to create a signed thing somehow. How are you
yes,
going to sign it? Out of scope. You make it up yourself. So in order to actually use software statements for DCR in an ecosystem like MCP, they have to go and define specific semantics about where do the keys come from, how do they get deployed, what exactly goes into this, and that ends up involving creating a bunch of new stuff in the MCP spec.
yeah,
And so it just seemed like it was a not the best option for that community, because it wasn't standardized enough, and even then, like you still have these other problems of DCR of client IDs getting stale and getting deleted or whatever, right? So
I had a conversation with Lucas from Radium about SSAs, and it wasn't even clear to me like what's the right lifetime for a software statement. Um, is it 5 minutes, 15 minutes? I think open banking uses like 15 minutes. Um, but could they be longer? Is it just an access token for dynamic client registration, in which case it probably shouldn't be longer? And then if it's really short, then maybe could you post it as an extra parameter? Can you reference a document, but also maybe give some extra parameters sort of on the fly in your,
yeah, you could definitely do all those things, but that's where I see the annotation-based client authentication actually solving it. Where like that is a mechanism that gives it's a new header that goes into the request that has the specific behavior of being a jot and being signed by keys that are found at this other server. The part that's left out of scope of annotation-based client authentication is how the mobile app obtains the that
yes.
jot, right? And that's where you can start doing things like you're talking about. Of is it a Apple backend that validates generates the first assertion, or is it just it's your MDM software that can generate this first assertion and validate the software? That feels like the much clearer path to go down to me for solving these kinds of things.
Could the attestation be an SSA?
I um I think the input to the thing that generates the attestation could be yes.
Yeah.
But like the client attestation based client authentication specifically defines the format of the thing used in the header. But
Mm,
it doesn't define how that is obtained. And that's where you can use things like Spiffy even, right?
yeah. Interesting. Let's connect this all to MCP a little bit because that's the hot topic of the day, and I know you're doing a lot of work there. Um, so, what's the reaction from the MCP community for this spec? And are there any gaps still left to fill that maybe this doesn't satisfy for them?
Yeah, so I mentioned this to them because this spec is not new. We've been working on it for over a year, and it's
Yeah,
based on ideas that have been around for a long time, right?
yeah,
Um, so I mentioned this to them back in April when I first started getting involved in the MCP OAuth. And again, the decision then was this is too new. Let's stick with DCR for now, whatever, right? And then like
yeah.
6 months later, everyone's hitting these roadblocks. So the OAuth working group adopted it a couple weeks ago, and the MCP core maintainers also adopted it around the same time to land in the November spec update. So in about a month, we should see an update to the MCP spec that references client ID metadata documents as the recommended way to do client authentication and client registration. Um, Feedback I've seen so far is that people generally understand the benefits to this and how it addresses all of the problems they've had and had direct experience with dynamic client registration, and are generally very optimistic about it. The gaps that still exist are desktop apps because we don't have the attestation APIs.
Mhm.
So it's not that they can't use it, it's just that it means that you can't do client authentication of desktop apps. But that's not worse than the current world of using DCR from desktop apps where you also can't authenticate them. And adding software statements into the mix doesn't help either because how do you authenticate the software statement? So it's all the same. It's all a problem on desktop apps, regardless, right?
Yeah.
Um, but that's one area that's sort of unsolved. And then the other is it's not immediate how to make it's not immediately clear how to make the leap from client ID metadata documents to using it in an enterprise environment where you do want to lock down which clients can access things. It is possible, but it's not immediately obvious, and it also requires new support from enterprise IDPs in order to be able to do that in the first place. Which I guess is actually the third consideration, which is that this is a new spec. There are very few authorization servers that support this right now. So
Just
I think
Aaron's in Aaron's basement.
yeah, just the one that's running on my Raspberry Pi right now. No, there are some, and like I said, BlueSky implements this, and it's in BlueSky, and there's other implementations of it and similar things. But the as far as like commercial or open source generic OAuth servers, those that category of things does not broadly have support for it yet, although that is already very quickly changing because of the interest in it.
I think it's priority number 3 for the Janssen auth server team. We have a couple other things that we're doing, which maybe even you worked on at some point. So it's probably your fault. We're still catching up with it. Um, what is now? I always ask this question, and everyone always pushes back. So it was accepted um, by the OAuth working group. It's on draft 3. We don't know. It could have draft 12 or draft 200. We don't know. But what are your feelings about do you have any sense of like how close this is, or how much stuff in there you think people might debate about, or how long this
Yeah,
is
yeah.
about?
Yeah. Always hard to tell for sure. One thing that's useful to note is that, again, it was just adopted by the OAuth working group, but has been around for over a year. So it's already gone through, several iterations and discussions. I've been presenting at the OAuth working group for a while now,
Hmm.
for over a year. So there has been a fair amount of discussion already. How much will there be now that it's an adopted draft? I don't know. We'll find out next week. I have it on the agenda for the IETF meeting next week. My sense is that most of the changes that we'll see are not normative, as in they are things like security considerations. Of like, there was one very clear piece of feedback I got from the adoption call, which was we need to make it very clear in the document who this is for and like in what scenarios you should be using this. And because again, this is not intending to replace all client registration in all of OAuth. This is intended for a very specific scenario when you need to solve this problem, right? So making that very clear in the spec is important. So there's that. That's obviously not going to change in implementation. Things that could actually change implementations, I'm going to try to keep those to a minimum because like I'm happy with how this works. BlueSky's implemented it and it's working well. I don't think it needs to change. There's a lot of bike shedding you could do for things like um, I don't even want to go there. There's a lot of bike shedding that's definitely
Yeah.
possible for how you could do things differently, but um, I'm hoping to keep the actual protocol changes to a minimum. But I would expect things like maybe stronger requirements for respecting cache headers, or maybe there's actual advice for how it gets linked to the attestation-based client authentication draft instead of just kind of leaving it up to people to figure out. Um, we'll see. We'll see.
Uh,
Always hard to tell with these things.
so you might not know the answer to this one, but Dick Hart has been a consistent critic of dynamic client registration. He seems to hate DCR. Did you get any feedback from does Dick like this a little better, this idea?
I don't know if I've actually heard Dick's like pushback on DCR recently.
Okay.
Um, I don't know if that doesn't ring a bell. Interesting. Um, no, I don't know. I haven't chatted with him too much about this one in particular. I've been talking with him about a bunch of other things that are in the works, like OAuth 2.1. But
It reminds me of in a lot of SAML IDPs, the identifier for the entity is also where you get the metadata. I know for sure in Shibboleth it's like that, but it's a convention really. It's not really a rule. It's just a convention.
mm,
Um, but in the convention in the SHIB IDP was always that the metadata URL is your entity ID. So it reminds me of that a little bit. Um,
it seems like a good pattern. I mean, everything else in OAuth has identifiers, right? Authorization servers are identified by a URL, and that's the issuer URL. And now we have resource servers identifying themselves as a URL as well with the new protected resource metadata spec, which is an RFC. So why not clients having an identifier as a URL?
I think the URL is almost like that's a collision resistant identifier that's just so ubiquitous today. But what
Yep.
URL is a question, though. For
Yeah.
example, I've heard a lot of people assert that the identifier should be a spiffy URL, obtained through a spiffy.
Mm.
And not and so this is sort of, it also reminds me of OAuth scopes a little bit, where OAuth scopes should be a best practice. They don't have to be
Yeah.
anything, but a lot
Yeah.
of times they're a URL. And in Google, those URLs actually resolve, but they don't return any metadata. So I don't know what the point of them resolving is, actually, but they do
Yeah.
resolve.
Yeah.
Maybe you can check if it's a valid Google OAuth scope, just by checking to see if it returns, and that's about it. Um,
No, I think it is a good way to think about it. As the other way I describe it is that it's now we have a global database of client IDs, right? So, and it's URLs, and there is a convenient structure to them as well, because you can do things like check the domain name, and the domain name has meaning. You can like link clients on the same domain to some policy, or you can have known good domains or known bad domains, and you can do a lot of useful policy driven things around these client IDs now that they're in this global namespace of DNS.
Well, the birds are flying, which means we're at 45 minutes. Let me just give you a quick last thoughts, because I want to make sure if you have anything else to add that you have the time to do that. Any last thoughts?
I guess I would say, like, if this is interesting, go take a look at the spec. Let me know your feedback. Let me know your concerns. One of the things I want to make sure, again, we do in this, now that it's adopted and are going to push through the process, is make sure that all of the concerns and are addressed in the spec, whether that's with advice or with changes. So definitely, feedback is welcome. And if you want to try it out, we'll leave some links in the show notes to where you can read more about it and see some of the sort of demo sites and demo apps and stuff that use it right now.
Okay, well, my feedback is, yay, Aaron, this is an awesome spec. And
Thanks.
I think, I've seen Tobias had a solution for this, Tobias
Mhm.
and Christina a while back, but I really, really like this solution. And I think it's a great new option. And it's one more piece of evidence that OAuth is still evolving. And there's still new stuff happening, and there's still important innovations. So good work. Thank you for spending the time and listening to everyone to make it happen. Um, Next episode will be next Tuesday. It's been 149 and a half is because I completely messed up the schedule, but we'll be back on schedule next Tuesday with episode 150, which is some type of fancy proxy we're going to talk about. Aaron, thank you so much for making the time today on short notice. Thank you, audience.